A lot of applications involving proportionality relate to trying to have the same proportion or to achieve proportionality with quantities. So that's what we're going to look at in our next few examples, is say we want to continue to have the same proportion in a situation. So in that case, when you want to have proportionality, you're going to want to make sure you have two rates that have the same fraction. So one rate might be A over B, and you want that rate to be equivalent to a different rate like C over D. So basically we're in a situation where we want to make sure the rates are equivalent to have proportionality. Okay, let's start with an example and you'll see how that works out. Salama earns a salary of $2,400 per month, from which she saves $150 each month. Her salary is increased to $3,000 per month. If she keeps the same rate of savings, how much will she save per month? Okay, so notice it says if she keeps the same rate of savings. So that means we want the savings to be proportional as her salary increases. Now to do that, what we want to do is to create a rate. So let's start with what her savings is like initially with the old salary. So we'll start with the initial salary. So the original rate would have been that she's got a salary of $2,400 per month and she saves $150. So let's look at it this way. So we want to create a rate with that. Now it doesn't matter whether we put the 2,400 on top or the 150 on top. It's really your choice. I'm going to put the smaller number on top just because sometimes it looks a little nicer that way. Now her salary is increasing to $3,000. So what I want to achieve is I want to achieve a situation where my new ratio or rate is the same as what I had before. To do that, I need to set up the rate the same way or the ratio the same way, depending on the situation. So remember, we had the savings in the numerator and we had the salary in the denominator. So when we create our second ratio, we want to set it up the same way. So the salary is now 3,000. So think about where the salary was in the first ratio. It was in the denominator. So we want to put the salary of $3,000 in the denominator. Now, when we do this, we're trying to figure out how much she's going to save per month. So this savings is unknown. In algebra, we would use an X or a question mark. So basically, you end up with this equation. And if we want things to be proportional, we just need to solve this equation for the x, the unknown. I'll show this with the algebra, and then I'll show you a different way you could do that. And it'll be your choice on future examples how you want to go about it. So in algebra, there's a really nice way we can solve proportion problems like this, and that's what's called setting cross products equal. We can only do this if you have a fraction equal to a fraction, but if you do, you can multiply across diagonally the equals, and that cross product because it's a multiplication, will be equivalent to the opposite cross product. So 2,400 times x will be equal to 150 times 3,000. So 150 times 3,000 would give me 450,000. Lots of zeros here. Watch yourself that you don't lose a zero there. And then it's really simple to get the x by itself because remember, any number and x here right next to each other, remember those were multiplied. So the way we undo that is we divide out the 2,400. So pretty much just a few quick calculations. And now we've got that our unknown amount was 450,000 divided by 2,400. And that's 187.50. And remember, we were looking at a dollar amount, how much she needs to save each month to have the same amount that she saves. So $187.50. So that's a quick algebra way of doing it. And you may have seen that in a previous algebra class. It's something that often people kind of like, that setting those cross products equal. It often feels pretty good to do that. So I find that a lot of students remember that from an algebra class they've taken in the past. So you're welcome to do it that way. Another way is to look at the initial ratio of 150 over the salary of 2,400 and actually calculate that ratio. So 150 divided by 2,400. This would give us a ratio or a decimal of 0.0625. And if you think about that, this, remember, because we have dollar signs that are the same, if we move the decimal point 2 places, this is saying that she's saving 6.25% of her salary. So if we want to have that consistent rate going, all we have to do is multiply this current rate to her new salary, 3,000, and we will get how much she needs to save out of that 3,000. So 0.0625 times 3,000 gives me exactly the same savings of 187.50. So Salama will save $187.50 per month. Okay, so 2 ways to do it, your choice which way you want to. Let's look at a second example. During the first 665.6 miles of their vacation road trip, sorry, I had hesitation there with the decimal point, the Riveras used 32 gallons of gas. At this rate, so continuing this proportionality, how many gallons are needed to finish the remaining 530.4 miles? So once again, one thing to be aware of is that we want to set up our first scenario as a single ratio. All right, so let's look at this first part of the trip. 665.6 miles over 32 gallons. And I said ratio, but actually this would be a rate because the units are different. Okay, so that's going to have to be equal because I want to continue this rate for proportionality. It's going to have to be equal to the rate I would get if I look at the remaining number of miles. So think about where I put miles. I put miles on the top of my first fraction, my first ratio. So I'm going to put miles on the top in my second ratio. And I don't know how many gallons I'm going to need, so I'm going to put a question mark on gallons there. Now I've got those units in there, but if that is a little confusing to have miles and gallons, let's just take them out. So we've got the simple 665.6 over 32 equals 530.4 over x. Again, we've got this proportion problem. We can use real basic cross product algebra to solve this. So 665.6x equals 32 times 530.4. I'll just do that calculation. 32 times 530.4 gives me 16,972.8. And then we would, to get x by itself, right now 665.6 is multiplying x, so we're going to divide. So x will be equal to 16,972.8 divided by 665.6. So let's do that division. And we get 25.5. Now remember what we were finding, the x was the number of gallons of gas. Now let's just ask ourselves if that makes sense. The Riveras, rather, I don't know why I want to say Rivieras, I think because I was watching a TV show related to the Rivieras a couple of days ago. The Riveras used 32 gallons in their first 665.6 miles of their vacation road trip. And the remaining trip is actually less miles. So it would make sense that they use less gallons if they're using it up at the same rate. And we do use less gallons. So the Riveras will need another 25.5 gallons of gas to complete the trip. Example 3, we'll look at a soup recipe. So a soup recipe calls for 1.5 cups of tomatoes and 4 cups of broth. You have 2 cups of tomato and want to use them up. How should you adjust the broth? Okay, so we want to be consistent so that the recipe still has the same proportions when we increase the tomatoes. So first, just like we've been doing before, look at what you should use and make a rate out of it, or a ratio in this case, because the units are the same. 1.5 cups of tomatoes and 4 cups of broth. So remember, I've got the tomatoes on top and I've got the broth on the bottom. And that's equal to, okay, when I change this recipe, I'm going to have 2 cups of tomatoes. So tomatoes are on the top, so I'm going to have 2 cups on the top. And I don't know how many cups of broth I need. That's what I need to figure out. I need to adjust the broth. So I really have this ratio, this proportional relationship of 1.5 over 4 equal to 2 over x. So I can use cross products. So calculating 1.5x is equal to 2 times 4. 2 times 4 is 8. So to solve for x, I would simply divide both sides by 1.5. So 8 divided by 1.5. Feel free to use your calculator. I'm grabbing mine real quick. We get 5.33333333333333. 3 goes on forever. Now, that's definitely 5 cups, but let's think about what 33333 is. In cooking, at least in this country, we often measure things in quarter cups, half cups, and third cups. Now, a quarter cup would be 0.25 of a cup. Half cup would be 0.5. A third, if you've ever divided 1/3 and give it a shot in your calculator, that is 0.33333 repeating. Okay, so this is actually saying 5 1/3 cups of broth would be needed. Okay, and a last example. The maintenance bill for a shopping center containing 180 square feet is, sorry, that should be is, $45,000. What is the bill for a store in the center that is 4,800 square feet? And let's assume proportionality here, that the stores are charged in a proportion based on their square footage. Okay. So just like we've been doing in all the other examples, what we want to look at is the initial information we've been given related to the entire shopping center. So we're going to set up a rate based on that. So 180,000 square feet divided by $45,000. And we're going to, because we want this to be proportional, we're going to set this up so that it is equal to the new ratio. We're going to force it to be equal to the new ratio related to this single store. So notice I've got my square footage on top and my dollar amount on the bottom. So, and the information I've been given is related to square feet. So I'm going to put the square feet on top so that I'm consistent. You need to make sure your ratios are consistently set up. And then I don't know what the cost is going to be. So it's X dollars. So again, you don't need to keep those units in for the calculation. Sometimes it's a little bit less cluttered if you take them out for the algebra. And again, using that convenient cross product idea, we get that we have 180,000 times X equal to, now again, use your calculator and watch your zeros here, 4,800 or 4,800 times 45,000. Make sure you get all 3 zeros and no more. So this is 216 million. Look at all those zeros. Make sure you've got 6 zeros there, because I've got that all in. And we're going to divide that by 180,000 to get X by itself. So when I divide by 180,000, that's 216 million. I know there's a lot of zeros here, just don't lose any of them. Divided by 180,000. Our final answer isn't quite as bad, but it is $1,200. Okay, and remember the square footage of the entire shopping center was much bigger than the square footage for the single store. So your price for maintenance is going to go down quite a bit. So the price for maintenance was $45,000. It makes sense that it's gone down to $1,200. So $1,200 maintenance bill for the store.